ang unit is Kelvin, pressure is, tingnan natin. Okay. So itong tatlo, TC, PC, and eccentric factor, W, nasa handbook lang din yan, yung tatlo. Critical temp, critical pressure, eccentric factor. So if you were to hover sa physical chemical data, section 2, and then thermal expansion and compressibility, page ito, 2-182, makikita nyo yan doon. Yan. On table 2-106. Kita ba? Okay. If you were to open also your own handbooks, kita nyo yan doon. Ang hinahanap, critical temp, critical pressure, and eccentric factor. Okay, so before anything else, you need to identify ano yung fluid natin. Ang fluid is N-butane. So this is gaseous butane, an alkane, C4, no? Then, check natin si N-butane sa Paris. Based dito, N-butane or the normal butane is ito yung butane. Yan. So, makikita sa columns yung compound name, formula, CAS, molecular weight, critical temp in Kelvin, critical pressure in MPa, and critical volume, critical compressibility factor, tsaka eccentric factor. Yan. So, we need the TC. Anong TC ni butane? Kikita natin yan dito. TC is 425.12. 425.12. Then PC. PC is 3.796. So this is MPa. Megapascal. Tapos, meron tayong eccentric factor na ito, 0.20016. Okay? And now, with these three data, kaya nating masolve na ang B0 and B1. So let's try B0. So equals 0.083 minus 0.422. Then divided by TR raised to the power of 1.6. Yan. So kita dito na based sa ating formula, sir, ba't nyo tinype po yung TR? Wala po, di po ba siya may cell value? You can do that, no? Hanapin natin yung TR, pero wala pa tayong nasusolve na TR. So with that, lagyan na lang natin na TR. So may hashtag reference, meaning may kinocall tayo na cell in terms of its name na TR, kaso wala siyang mahanap. So cell reference error. So we can compute for TR. So ano ba ang definition ng TR? TR is just the ratio. No, tawag ng TR is reduced temperature. So that reduced temperature is T over Tc. Whatever the given temperature divided by the critical temperature. Yan lang yan. So which is why if ko-compute ka ng TR, it's just T over Tc. So to compute for TR, that's equal to temperature na 510. So refer to the initial 510 na cell divided by TC. Critical temp is 425. So you get a TR of 1.19966. Alright. So, given na may TR ka na dito, no, try natin ngayon yung renaming of cell name through name box editing. So from H37 to TR. Yan. So sir, paano po mag-change ng name ng isang cell? So when you change a name of a cell, that is true throughout the workbook. So ito, if I were to hover my mouse dito sa cell na to, active cell, H37 ang name ng cell. Let me change that to TR. So I'll just type in TR and then hit enter. ang B0 ngayon, may calculation siya. May nire-return na siya na value. That's because we have defined that this cell is named TR. Yun yung gagamitin ngayon ni B0 to compute for its value. So, clicking this formula, kita na yung blue, yung active cell, TR. Ito siya. So, kinocall niya na ngayon yung 1.99966 na cell. Doing the same on B1, ganun din. So, mas mabilis mag-compute. Equals 0.139 minus 0.172 divided by TR raised to the power of 4.2. If you can observe, pag nagta-type ka ng TR, may lumalabas na icon, no, na shows cell in cell na naming. Yan. Then hit enter, you get 0.058927.726. Yan. Okay. So, if ganito may mahabang mga decimal and you want to trim out the decimal, we have here these function, itong nakakama, meron ding percent, may dollar sign. Usually, itong comma ginagamit ko to reduce it to 2 decimal places and then extend lang, let's say gawin kong 5 decimal places. Pwede din reduce. So, I just use 5 and then number na format. Yan. Now, we can solve for B. Okay? Paano natin masasolve si B? May formula na tayo dito, no? R, TC, PC, B0, omega, B1. So what we have to do, para mas mabilis, we can name each cell required. So yung R gas constant, pagpalagay natin, i-name natin to as RK. Hit enter. Tapos si TC, rename natin na TC, hit enter. Si PC, rename natin na P sub C, enter. Yung eccentric factor, name natin W. Yung B0, name natin as B0. Tapos yung B1, name natin as B1. So, when we type in the formula for B, pwedeng manual natin na isa-isahing select yung cells or pwedeng i-type in na lang natin. So, RK times TC divided by PC times B0 plus W times B1. Yan. So, I'm typing not letters and numbers but instead yung mga names ng cell na nirevise or binago natin. So, when you hit enter, lalabas yung value ni B. Okay? Ganun lang din if we manually select the cells. So, equals R, ang R is ito andito sa taas, times PC over PC times B0 plus omega times B1. Yan. So, same values lang yung lumalabas. Okay. With that, yung B natin should have a unit of tawag nito, liters per mole. Okay. So check, ang pressure pala is naka megapascal. And then yung R na ginamit natin, gas constant, has a unit of bar. So we need to convert first yung MPa to bar pala. Yan. So to convert, usually yung yung MPa, 1 MPa is just 10 bars. So times 10 lang natin. So we need to use the 37.96 PC. Palitan natin yung PC na ito. Yan. So ito yung ating tamang value ng B. This is the second coefficient, second virial coefficient, B. So gagamitin natin to solve the volume, molar volume of the gas. So, kanina, nag-compute nga tayo ng ideal gas volume. So, this is V. Gawin natin to ideal. So, I need to compute on the real gas, no? Estimated real gas volume. So, with that, going back dun sa formula, anong definition ni Z? Ito lang siya. Yeah. Okay. And then, Since we're computing only using B, so kakat natin, itatrancate natin yung formula niya hanggang dyan lang. So Z equals 1 plus B density, which is also equal to PV over RT. Ayan. So before we proceed, may questions ba? Clear naman, follow, or hindi. So, andito lang din naman yan sa handout. So, which is binigay ko sa inyo. Just have to read further, no? Okay, so let me proceed. So, paano natin masolve ngayon yung V, which is the uh, tawag nito, molar volume. So, we need to equate the two. Just have to get Z equals 1 plus B density, which is also equal to uh, PV over RT. So, mangyayari ngayon, it will become uh, PV over RT equals 1 plus B. So, this time, express natin yung density as 1 over V. So, meron ka ditong B over V. And then, lipat natin lahat on one side to get a working equation for Excel. PV RT minus 1 minus B over V. So, this is now equal to 0. So, ito yung formula natin to compute for the molar volume. All right. So we have here V real. So kanina, volume ideal 1.6961 liters per mole. Yun yung volume ni gas at 510 Kelvin, 25 bars. Ngayon, compute natin yung volume, real gas volume. So ang unit dito, it should be the same, liters per mole. At yung equation natin should be based dyan sa equation nito. Okay. So, just have to type in so pressure. So, ang actual pressure natin is itong P, 25 times V, which is ito, yung real volume V divided by R, which is the gas constant. Ito lang yun. Times temperature. Ang temperature na gagamitin is the 510 Kelvin. Minus 1 minus B. B is this one yung na-compute na natin. Then divided by V, which is the real volume. Ito, E50. Okay? When you hit enter, encounter kayo ng error, that's div 0. That means yung equation nagsosolve with a 0. So a number divided by 0 is indeterminate, kaya nire-return na Excel na walang value. So hindi niya kaya i-solve. What you have to do is to fill in yung value estimate lang ng real volume. So, typically, ang ginagamit pang estimate is yung value ng ideal gas. Okay? So, puntahan natin yung sa cubic equations of state. If you can recall, you have here Van der Waals, Redlich Kwong, Suave, Peng Robinson. No? Itong mga to just follows this formula. Unlike sa virial equation na ikaw pa magko-compute ng B, magko-compute ng B0, B1. So, ito, ang constants niya madami, pero it's already given majority sa table na to. Okay? So, itong table can be found sa Paris din. So, we go to mathematics, then scroll up ka lang or few pages before math, andun yung discussion on the equations of state. Yan. So, dito tayo. Yung kanina, Lee-Kessler correlation, and dito siya. Possibility factor. Yan. Lee-Kessler method. Pangalawa is the cubic equations of state. Dito siya. So, you have here Z, ito yung formula, 2-70. And the rest of the functions, constants, andito. Table 2-172. Okay? Ngayon, since madami kang options, alin yung which is which, no? Si Peng Robinson daw sabi is for liquid densities. Per vapor liquid equilibrium, vapor densities, ginagamit yung SRK or yung suave, red liquid, itong pangatlo. And then, in solving the cubic equation for volume, convenient initial guess is to find the vapor root, no, using ideal gas value. So ito yung sinasabi ko na you can estimate or guesstimate na ang real value is likely malapit sa ideal gas value. Tapos, si Excel na mag-a-adjust to compute for the real value. So type in natin dito ano yung ideal volume, 1.69. Okay? Upon typing in 1.69, ang lumabas na equivalent value ng equation is 0.1179. If kita nyo, no? Kita nyo bang screen? Alright. So what we have to do is to adjust the value of the volume, real volume, in such a way na ang equation mag-equal to 0. Kasi yun yung nasa formula. So what we have to do, dito papasok yung goal seek na function. So how do we do goal seek? Okay. So first we go to data tab and then what if analysis, and then makikita nyo dyan yung goal seek. So goal seek, find the right input for the value you want. When you click goal seek, lalabas yung pop-up box showing you 3 fields. First field, set cell. Pangalawang field, to a value or to value. And then third field, by changing cell. So what you have to do, ang set cell is yung target natin, which is yung equation. So click natin yun. Set natin siya to a value of, usually, kayo nagsiset nito. Ang value is base equation 0. Pwede siyang 0.0001, something that approximates 0, or pwede din negative 0.00001, negative 0.00001. So this approximates 0. Yan. So by changing cell, alin yung cell ngayon na magbabago to get to the value of 0. So of course, ang iset natin na magbabago yung virial real equation. Virial real volume. Okay? So with that, pag kinlik ko ito na okay, real time na babaguhin ni Excel ang value na 1.69, and hihinto siya in such a way na yung value ng equation is approximately equal to sa sinet natin na value. Okay? So, status, goal seeking with cell E51, found the solution, target value, current value. When you hit OK, ngayon adjust na yung values. So, if I were to summarize, so ito yung equation, equivalent siya to 0 na approximately. Pag nira-round off yan, 0 na yan. And then, ang volume ngayon, real volume is at 1.45810. Okay. So, compare yung ating ideal gas as a volume of 1.6961. But in actual, or yung real volume ng gas, hindi ideal kasi mataas na pressure nito, no, 25 bars. In actual or real ay nako-compress pa siya further. Gas molecules tend to, nagsisip or nag-compress. Yun yung term. Nagko-compress sila further versus the ideal. Kasi meron kang mga natitrigger dyan na attractive forces. So this gas is butane, which is hydrocarbon, alkane, and they're known to be nonpolar. Yan. So walang repulsion masyado. ang each molecules, which is why yung ideal value 1.69 compare natin sa actual mas mababa kasi parang absence of the repulsion forces between butane molecules. So if we compare natin yung percent difference between ideal minus actual, so meron tayong ilang difference. Percent difference is equal to, yeah, around 14% difference. So which means that mas mataas yung ideal value kaysa dito sa real gas. Yan. So engineers usually use the truncated form na Z equals 1 plus B density. So dito lang yun nanggaling. This is to actually estimate the correct volume kaysa ideal. No? Ang laki ng difference kasi yung 14%. Makikita yan sa handbook. Dun tayo sa thermodynamics ulit. And we go to the real equation of state, page 11. Yan. Sinasabi dito, in practice, no, truncation is to two terms. So, Z equals 1 plus BP over RT. So, for engineering purposes, ganun yung ginagamit. Yan. So, if ever na gagamitin yung C, yung Charlie, yung pangatlong coefficient, no, i-extend lang natin yung calculation. Magiging Z equals 1 plus B density plus D density squared. So, ang magiging formula ngayon, if i-extend natin to, will become, mag-plus tayo dito, no? Plus C density squared. Or this will become plus C over V squared. Then, equation, BV over RT minus 1 minus BV minus C over V squared equals 0. Yan. And this equation, gagamitin lang to pag available yung values ni C tsaka yung value ni B. But pretty much it's straightforward because you have the formula of the C0 and C1, you have the formula of B0 and B1. Yan. So any questions? Gets nyo ba paano gumamit ng goal seek? So yung essence dito again is yung kanina nag-convert tayo ng mga units. Pangalawa, paano gumamit ng renaming ng cell. Pangatlo is yung goal seek na feature. When we want to adjust certain values to desired limits or values. Okay. And then pangatlo, yun nga, goal seek. So, any questions sa goal seek? Intindihan naman, no? Okay. So, if walang concern, proceed ako. Ngayon, let's assume na we have may madaming kang pressure. Titingnan natin yung effect ng increased pressure sa value ng ideal versus real gas molar volume. So, dito meron palang ito cubic equation of state, then racket method. Itong racket method, ito ay para sa liquid na density naman. So, ang gagamitin dito is yung RTC, PC, ZC. Yeah, lahat ay nasa Paris na table. Then, may definition lang ng Q, which is the reduced temperature. A function of reduced temperature. Merong Goodman method, which is for solids density or molar volume. Then, yan. Lastly, application, ito ay yung nasa assignment nyo na. Kaya nyo na, nitrogen gas, 40 degrees Celsius, 29 PSIG. Ano ang kanyang volume in terms of ideal gas, virial, Lee Kessler, van der Waals, and Suave. Okay? So, dagdag ko lang dito, assume natin na how would you like to present this visually, no, para maintindihan na ang pressure ay may effect sa real gas volume. So let's examine, no, impacts ng pressure. Let's say nasa 25 bar to, gawin nating 15, 20, 25, 30, 35, 40. So we have these data points in terms of pressure. Gawin po natin 45. And then molar volume. Let's say ideal muna. Ideal gas. So volume, unit of volume is liters per mole. Okay. So paano computein yung volume in terms of ideal gas? So just have to follow the earlier formula, RT over P. So R times T over P. R is the constant, RK. So kanina ni-name na natin, nag-name na tayo na ang gas constant should be RK. Times pressure, uh, temperature no, RT over P. So temperature is fixed yung 510 Kelvin divided by pressure na 15 bars. You hit enter, so max value ka na, and then we use autofill no, to fill out the rest of the data. Okay, either double click or i-drag natin yung cell. So ngayon, lalabas na may zero value. So which is unusual. So when you click on the cell and inspect, so in terms of the formula, so tama naman ang RK, tama din yung pressure, pero yung E23, ayun, gumalaw siya. So if you can recall, ito yung relative referencing. No, we don't want the cell's value to move around pag nagka-copy and paste tayo ng formula. So what we have to do is absolute referencing. So dun pa lang sa start, yung itong unang formula, i-absolute value na natin yung 510. So what we have to do is to put dollar sign no, before the letter, before the number, or press F4. So when I press F4, lalabas yung dalawang dollar sign, hit enter, and then autofill. So may value na per pressure. So you can see 15, 20, 25, 30, 35, 40, 45. You have those values, ideal gas. Okay, so pagpalagay natin, ito yung ating ideal, color green. Now, if you were to compute real gas, ayan. So, ano yung volume niya? Volume is based on the same equation. So, ito lagay natin na yun yung orange. Okay. Then, we have here the equation. Should be equal to 0. Okay. So, equation, una, copyhin lang natin yung equation na equals pressure times volume. So, ang volume na ilalagay natin dito is yung real gas volume divided by the RK times temperature. So, we're fixing the temperature. So, click natin yung 510. Then, put absolute referencing. Wait lang. Yan. Kita niyo ba yung screen? I-share ko ang screen ha. Okay. Then, minus 1 minus B. So, itong B natin is also a constant. So, lagyan natin ng absolute referencing divided by volume na F64. So, when you hit enter, div 0 siya. So, bakit siya div 0? It's because wala pang value yung real gas volume. So, kanina sabi na ang best approximate for the real gas is the ideal gas. So, i-adjust na lang accordingly. So, what you have to do, assume natin at first na ito yung value niya. Copy lang natin, paste as values. Yan. Then, check natin yung equations, then autofill. Yan. So, isa-isahin natin to na dapat mag-equal siya to 0. So, punta tayo sa data, what if analysis, goal seek. Then, set natin yung cell na to 0 by adjusting cell, yung real gas volume. Then, real time siya i-adjust na yung cell. Doing the same on the rest of the data. So, set cell ito to a value of 0. Changing cell, this one. Hit enter. Okay, and then goal seek to a value of 0 by changing cell, this one. Yan. So, real time siya na ina-adjust ni Excel. To 0. Okay, another one. Okay, so last value. Okay, so complete na, no? So you can see that the equation here should be equal to 0 has or yung column approximately 0 naman talaga na, no? So if i-round off mo yan lahat, 0 yan, no? Yan. Okay, and then we have to visually show this one. Dito papasok yung ating paano mag-insert ng scatter plot or XY plot. Yan. So ito ay one of many charts na pwedeng i-insert sa Excel. So pwede din natin magdagdag ng percent difference. When you say percent difference, yung gaano ka iba yung real gas sa ideal. Yan. So autofill percent. Yan. So you can see here, as pressure is increased, iba-iba talaga yung effect niya, no, in terms of the ideal and real gas. So mas ma-appreciate to pag may visual tool ka, which is in this case we can insert a scatter plot or XY plot. So how do we insert scatter plot? Okay, so when you select the first column, the pressure, and then the second column, the ideal gas volume, go to insert, and then makikita nyo dyan yung recommended charts. So we used this one, yung scatter or scatter na may smooth line. So we can use this one, yung scatter na may smooth line. Okay? Tapos, when you click on this chart, lalabas yung setting na chart design. We have there a lot of features na pwede nyo paglaruan. Dito sa chart style, quick layout. So, add mo lang tayo ng isa pang data. So yung kanina, we can set this as the ideal gas and then add tayo ng virial gas. Series X values, that's 15 to 45. And then Y values, yung color yellow na naka-highlight ng yellow. Yan. Click OK. Tapos, you can also add uh, mm, I think yan. Kita dito yung difference no ng chart. Ang difference ng dalawang trend. Una, yung ideal gas, pangalawa yung real gas volume. So, may impact si pressure. As pressure is increased, iiba yung actual gas volume versus ideal. So, hanap tayo ng pwedeng design. Yan, I think ganyan, no? Okay naman na yan. Quick layout, pwede natin maglagay ng access titles. Yan, so you can play with this one. Depende sa paano nyo siya i-represent. So this one is pressure, yung nasa x-axis. Sa x-axis is volume. Yan. Chart title, pwedeng gawin natin tong yung second virial equation. Yan. Okay. So kita, no, yung difference ng dalawa. Ideal gas volume, tsaka yung real gas volume. Then you can also add, I think, itong percent difference para mas maganda. Kita mo siya. So click again this chart, go to chart design, select data, add. So series name, ito, percent difference. X values, 15 to 45. Y values, itong percentage value. Okay. Click OK. Yan, lalabas na siya sa screen. So, kita din dito na as pressure is increased, bumababa yung volume pero mas mababa yung volume ng real gas calculated kaysa sa ideal gas. So, to put emphasis dito sa percent difference, pwede natin siyang ilagay or pwede natin i-refer on a secondary axis. Yung primary axis dito on the y-axis is volume, no, liters per mole. Pero iba unit nung ating percent difference kasi percentage siya. So we can add what we call secondary axis. So how do we do that? You just have to click on the trace na percent difference, then right click, format data series, lalabas yung option na primary or secondary axis. So if we click secondary axis, yan, close. So andito yung percent difference on a different scale kasi naka-refer siya this time sa right na axis. So itong right axis, pwede natin lagyan ng label din. So dun tayo sa chart design, add chart element, axis, title. Yan. Tapos lagyan natin na yan ay percent difference. Okay. Yan. So you have there scatter plot showing the difference between ideality or ideal gas versus a real gas. So you can work with this one, pwede nyo gamitin, pwede nyo ding dagdagan pa using the C. Ano kaya effect sa volume kung idadagdag pa natin yung C, yung third virial coefficient? Another volume yon, pwede siyang isa pang trace dito. Or you can also add itong van der Waals or yung suave, no, red liquong. Pinapa-compute dyan, ganun din, molar volume lang din. So, with the aid of Excel, you have to input only values, constants, interpret some equations, tapos wala na kayong kakalculate si Excel na mag-execute. So, Excel will do the rest. For di ba 06? So, next meeting is on Friday, no? 06, 7 to 8 p.m. Yan. So, we'll discuss yung next topic which is itong conversion, extent of reaction, selectivity, and yield. Siguro less discussion about anong meaning niyan kasi I believe alam niyo na yung mga ganyan. Kahit basic material balance lang yan. Ano meaning ng conversion, ano meaning ng selectivity, ano yung yield, parang analytical chem pa ito to, or material ba, yun nga, yung checkal, basic chemical engineering calculations. So, I think we'll be focusing then sa reaction networks. Ito, yung gagamit tayo ng tawag nito, matrix to represent equations, to predict if ano bang equations yung independent, alin yung equations yung makatulong to predict what we call reaction rates, tapos yung individual production rates. Yan. So, you may read in advance. Pwede nyo din gawin na ang assignment in advance. Dito na din naman yung mga instructions. Andito din yung mga problems lang. Yung reactant, number of chemical reactions, production rate, tsaka reaction rates. Okay. Yun lang. So dito, balik tayo. Do you have further questions ba or clarification? So to recap, una, gumamit ng convert functions, compute ng PBNRT, tapos nag-attempt tayo na mag-compute ng second virial coefficient. B, for butane, kinuha lang natin yung data from handbook and kinompute using this formula. Nag-rename tayo ng cells. So how do we rename cells? Just have to change yung andito sa cell box. Name box. Yan. Then goal seek. Then maalam na kayo dapat paano mag-insert ng scatter plot or XY plot. So dun sa charts, madaming charts dyan. You can check them all. Isahin nyo. So, pwede kayo maglaro anong pwedeng insert ng mga charts. But basic itong scatter plot. Yeah. Yun lang. Do you have any questions or final call clarifications? Calling once, calling twice. Okay, so if wala now, I think we can dismiss. No? Thank you for attending. Have a nice Sunday.